Okay guys, welcome to my YouTube channel. We're going to look at the types of triangles, which is the geometry of 2D shapes. Specifically, we're going to look at triangles. But the triangles that we're going to look at, we're going to look at the three types of triangles that we classify them according to their angles, and how in their angles we look at the largest angle of each. Now let's look at the first one. We call it's an acute angled triangle. Now it has a triangle, guys. It's a shape that consists of three sides. So when we talk about the triangle, the word tri means three. It consists of three sides. Now the acute angle, we look at the largest angle here. The largest angle here is 75, and this 75 is less than 90. So eventually all of them, they're less than 90. So we call this one, it's an acute angle. So because all the angles are less than 90, we call it an acute. We classify it according to the angles. Now the right angle, we look at the largest angle. We have 55, we have 35, we have 90. How do we see it's 90? We see the box. That means the BC line, BC and AC, they are perpendicular to each other. They form 90. So this largest angle is equal to 90. So if it's equal to 90, we classify this as a right angle triangle. So the right triangle, it has the largest side. We call it's a hypotenuse, and these two sides are not equal as well, and the longest side is greater than these two sides. Now let's look at another one. It's an obtuse angle triangle. We'll also classify it according to its largest angle. We look at the angles here, the interior angles. This one is 20 and 30 and 130. So the largest here is 130, and 130 is greater than 90, and the others are smaller than 90. So we classify it according to this bigger one. So since it's bigger than 90, we call it's an obtuse angled triangle. Let's look at the other three types of triangles that can be classified according to the sides and the angles. Now the first one is going to be what? A scalene. When we talk about the scalene, no sides or angles are equal. If you look at side AB and BC and AC, they are not equivalent. How do you see it? You see it by those strips. Those strips are not the same. And if you can see, that's 125 millimeter, 132, 180 millimeter. Even the angles that are there, they are less than 90 and they are not equal. Now let's look at the isosceles triangle. The isosceles triangle, two sides are equal and the angles opposite are equal, sides equal. Now if you look at here, AB, side AB is equivalent to side AC. How do you see? It's 9 centimeter, 9 centimeter, and you have the strips, the two strips that are equivalent there. So if these two sides are equal, these angles will be equal. So this angle is 70 and this 70, and that will be 40. And the interior angles of a triangle, guys, the inside angles of a triangle, they are equal to 180. 70 plus 70, it's 140, plus 40, it's equivalent to 180. Okay, now we can say that side AB and AC are equivalent, and BC they are not equivalent. So the angles there are equal. BC and angle B and angle C are equal. Right? This is what I've already said, that, guys. Now let's look at the last one, the equilateral. The equilateral, guys, it's all sides are equal, and the angles, the interior angles there, they will be always equal to 60 all the time. The sides are equal. That is 10 centimeter, 10 centimeter, 10 centimeter. You see all the strips there, that means all the sides are equal. Let's look at the properties of the triangle. The properties of the triangle here, we have to look at the property 1. Property 1, it speaks of the sum of the interior angles of a triangle is equal to 180. The angles of a triangle inside, as I've mentioned in the other video, that when you add this angle plus this angle plus this angle, they give you 180. We'll call these angles interior angles. That's very important. Now, property 2, the exterior angle of a triangle is equal to the sum of the two interior opposite angles. So, in a triangle, the exterior angle is this angle all the time. So, this exterior angle is equal to this angle plus this angle. So, the exterior angle is equal to the sum of the opposite angle all the time. This is how you write this. So, we'll say angle A, which is property 1, angle A plus angle B plus angle C equal to 180. That's the statement, and the reason will be sum of the angles of a triangle, or the sum of the interior angles of a triangle. Now, for an exterior angle, you say this is C1, this point is C. You say C1 is equal to the sum of angle A plus angle B. The reason you said the exterior angle is equal to the sum of the interior opposite angle. Let's look at this example. Now, in this example, it says find the sizes of an unknown angles and size of the following triangles. Always give reason for every statement. Now, we have the question. It says what is the size of C? So that means it wants the angle of C there. So in this triangle here, we are given the angle A and angle B, and it's an acute angle because this angle is bigger than 90. That's an obtuse, sorry. And then we're looking for C. So what we're going to do, we're going to use the interior, the sum of the interior. So we're going to say 50 degrees plus, okay, let's do it like this. You can say angle A plus angle B plus angle C equal to 180. The reason for that, we'll say it's a sum of interior angles of a triangle, right? So angle A is equal to 50 degrees plus angle B is 95 degrees, and angle C is the one that we're looking for, equal to 180. So when you add these two, it's going to be 145 degrees plus angle C is equal to 180. So we transpose the 145, so we'll have angle C is equal to 180 minus 145 degrees. Angle C is equal to 35 degrees. So that means this is 35 degrees. Now, let's look at the following question. Right, let's look. It says determine the size P. Size P, that means it looks for this angle. So we're given this angle and this angle, but we're not given this. So what we're going to do there, we're going to add all angles there. So we'll say angle P plus angle Q plus angle R, they are all equal to 180, and the reason is the sum of interior angles of a triangle is equal to 180. We're looking for angle P, and the angle Q we're given it's 45 degrees plus angle R is 60 equal to 180. So P plus, this is going to be 105, these two, and equal to 180, and then we transpose angle P, the 105, angle P is equal to 180 minus 105. So our angle P, it's going to be what? 75 degrees. So this angle is what? Is 75 degrees. Now let's look at the third example here. The third example, it says, now we're looking for length. It says what length of KM. Where is KM in this triangle? KM is this side, right? Looking at this triangle, seeing the isosceles triangle. Why? There are two sides that are equal there. So we're given the side KL or LK is equal to 50 millimeters. So if this side is equal to this side, as we are given there, the strips there, that means KM is what? Is also 50 millimeters. So the answer there is 50 millimeters, right? So we'll say our reason here, it's equal sides of an isosceles triangle. Equal sides of an isosceles triangle. Now it says find the size k, which means it wants this angle. We have to find this angle here. So finding this angle there, since I said it's an isosceles, guys, so that means angle M is going to be what? 38 as well. Because these two angles in an isosceles triangle, they're equal. So we are looking for what? For K there, right? So what are we going to do? We'll say angle L is equal to angle M, which is equal to 38. So we'll say equal angles of an isosceles triangle. So if we have M is what? Is 38. So we'll do the sum of the interior angles. So we'll say K, the one that we're looking for, plus L plus M equal to 180. The reason is sum of interior angles of a triangle, right? So the K is what? Is the one that we're looking for, and the L is 38 degrees and the M is 38, equal to 180. So K, angle K plus 38 plus 38, it's 76. It's 76 degrees equal to 180. So we transpose angle K is equal to 180 minus 76. Angle K will be equivalent to 104 degrees. So this angle is 104, right? So let's go to the fourth question. The fourth question, it says, what size S? What size S is? So size S, size S is this angle. If you look at this angle that we're given here, we're given a right angle triangle because of that. Okay, now we'll do the same, the interior angles here. The interior angles, we'll add them. So we'll say angle R plus angle S plus angle T, they're all equal to 180. Sum of interior angles of a triangle. So R is equal to 32 plus the S is the one that we're looking for, the angle S, plus T is equal to 90, equal to 180. And then we add the two. Angle S will be 180 minus the 2, it's going to be 122 degrees. So angle S, it's going to be 58 degrees. So this angle is 58 degrees. Okay, yeah, we have this triangle then surely you have an unknown internal interior angle and an unknown exterior angle. It says angle B and an angle with the size of 130 forms a straight line. Calculate the size of A and B. So they give you a hint there in the statement. They said angle B with this, they form 180 in a straight line. So we'll find A and B. So we can first find A, or we can find B. So finding A, you just add this angle plus this angle will give you A. Let's do that. So A plus 30 plus 130, they are equal to 180. So the reason for that, we'll say it's a sum of interior angles of a triangle. So A plus 160 equal to 180. So A is equal to 180 minus 160. So your A, it's going to be 20. You can even tell by inspection. 130 plus 30 is 160. So that means that is 20. But by calculation, it has to be that. So now we have to calculate B, which is an exterior angle. So we know the exterior angle is equal to A plus 130. So that's the law. So we'll say B is equal to 30 plus A, which is 20. So we'll say exterior angle is equal to the sum of interior opposite angle, right? So we'll say it's going to be 30 degrees plus 20. A is 20. We're adding these two. So our B, it's going to be what? 50 degrees. So B is 50. Honestly, it's correct because 20 plus 30 is 50, right? Let's look at the following one. This one, it deals with the interior as well. But now if you're looking at this triangle is an equilateral. So we're finding M and N. So these are adjacent angles in a straight line. This one, but both of them are unknown. So if you look at this triangle as an equilateral because it has equal sides. So the angle that has equal sides, it's an equilateral. That means the triangle, that means the angles inside here, it's going to be what? 60. Even M is going to be what? 60 to make 180. So we will say M is equal to 60 degrees. We will say equilateral triangle, or we'll say an angle of an equilateral. Let's say angle of an equilateral triangle, right? So if M is 60 and these two angles are 60. So what we can say, the N is an exterior triangle. We can say exterior angle is equal to the sum of the two opposite interior angles. So we can say N is equal to 60 plus 60, which is this 60 plus this 60. So exterior angle is equal to the sum of interior opposite angles of a triangle. So N is equal to 120. We can even do it like this. We can even do it like this and say, since this is a straight line and you know n, so we can add the 2. We can say m plus n is equal to 180, because these two angles are adjacent angles in a straight line. So we can say angles in a straight line, or adjacent angle in a line. So m is 60 and n, we do not know n, equal to 180. We can say n is equal to 180 minus 60. So n is equal to 120. Here's another example. This example, we are finding the sizes of an unknown angles and sides, and always give reason for every statement. Now, we have this triangle, and this triangle, once it has that external line or that extended line, that means it's an exterior, right? It's an exterior, which is it's an exterior angle, right? So the exterior angle, guys, it's always the sum of these two. If the exterior is here, it's equal to the sum of these two, right? All the time, this exterior angle is equal to the sum of these two angles. Okay, so we're going to find angle x and angle y. But looking at the triangle here, this triangle, it's an isosceles triangle. So that means x is equal to that. In an isosceles triangle, these two angles are equal. So now, in our case, x is equal to 62. So we'll say angles of an isosceles triangle. Now that we have x is equal to 62, we need y now. So y, if you're looking at these angles, when you add these angles, they equal to 180, and we have this one, and we are looking for that one. So we can do that. We can say y plus x plus 62 equal to 180, and we say sum of interior angles of a triangle. So we're looking for y, and we have x here, plus another 62 is equal to 180. So y is equal to 124 equal to 180. Then y is equal to 180 minus 124. So our y here, 180 minus 124 is going to be what? 56. So this angle is what? Is 56 degrees. Let's look at this one. This one, let's look at it very carefully. We have a triangle, the right angle there, and we have parallel lines there. So that means this line, it acts as a transversal, and this one, it acts as a transversal in those two parallel lines. And we have two unknowns there, x and y, and we have a 90 angle and the 40 angle are the interior angles of the triangle. So how are we going to get y or x? So the first thing that we can get there is x. So we can get x how? By saying this angle plus this angle plus this angle is equal to 180. So we can say x plus 90 degrees plus 40, they are equivalent to 180. We can say sum of interior angles of a triangle, right? So we'll say x plus 130 equal to 150. So x is equal to 180 minus 130. When we transpose x is going to be what? 50 degrees. So this angle is what? Is 50 degrees. So in order to get y, since we have parallel lines, we can get We can have the what we call, it's the alternating, alternating angles, which is x is equal to y in that case. Or we can use the U shape, which is the co-interior. This angle plus this angle, they equal to 180. Let's use the alternating angle first. Let me use this one. I'll say y is equal to x. And the reason for that, I'll say it's alternating angles equal because the line AB is parallel to line CD. Then, since we have x, our x is 50. So our y is also 50 because they're alternating angles. Okay, let's look at an alternative. The alternative, we have here what we called co-interior angles here. So this simply means that this angle plus this angle, they equal to 180. So I'll say y plus 40, which is this angle, plus the 90, which is this angle, they're equal to 180. So we say it's co-interior angles, supplementary, because line AB is parallel to CD. So y plus 130 equal to 180. So it's going to be 180 minus 130 if we transpose. It's going to be 50. So it's the same, but the easiest is this one, right? And what is the other way that we can do that? I guess those are the two ways that we can do that.